This lesson, we are starting on the review. I will tell you that this quiz you have to switch in between radians and degrees, okay? You should be in degrees unless you are graphing trig functions. The only place I will tell you to switch into degrees is for the trig modeling questions, because the first ones that you have to graph, you don't need to use your calculator, in my opinion. All right. On the quiz review packet, the first example here is actually trickier than what's on the quiz, because this one shows a left shift, which can get tricky for students. So I'm going to tell you, you can cross this one out. It's on the key if you want to do it, okay? But what I would like you to do is to go to page 4. In the middle of the back side is one that's more like what's on the quiz, okay? I'd rather review what's on the quiz. Does that make sense? Okay. So this question is on the middle of page 4. Tell me what you know. Tell me anything. Alexa? Midline is 3. He's not here today. Should I save it? Sure. Yep. Oops. I didn't make that dotted, but that's midline here. Okay. What did you say back there, Zach? Okay, so if this is 3, we'd be up at what? And down at 1. Okay. Do you still have something to offer, Brooke, or? Good job. Right pi over 4 is where it's going to start. And it's a sign. Can anybody tell me what that means? Naima? Starts at the midline, and it's a positive sign, so it goes up, back to the midline, down to the min, back to the midline. Okay? I made mine kind of big, so I want to write my ordered pairs on there. Okay. Somebody tell me the period. Yep, the B value in here between sign and this is nothing, so it's just 1. So the period is 2 pi. So then we say the quarter points are always the period divided by 4 added on to the phase shift. So 2 pi divided by 4 is how often we're going to have a quarter point, but we have to add that on to our phase shift over and over and over, okay? Now, you could reduce 2 pi over 4, but it has a common denominator with our 1/4, doesn't it? 1/4 plus 2/4 makes the next quarter point at, okay, and I'm going to just write it as an ordered pair, 3 pi over 4, 5. And the first one was at pi over 4, -3. Oh, +3. I don't know where I got a negative, sorry. Mine looks like a negative out there. That doesn't make any sense. Okay. Then if we add another 2 pi over 4, what's the next one? Yes, 3/4 plus 2/4 is 5/4. And that one's at the midline. Plus another 2/4 would be 7/4. And that one is at the minimum of 1. And the last one, anybody tell me the x value? 9/4. Okay. To double check, we finished at 9/4 and we started at 1/4. How far apart are 1/4 and 9/4? If you subtract, you get 8/4, which is 2 pi. Isn't that supposed to be the distance between those? It did not finish at 2 pi because we shifted it to the right. Any questions? Okay, if we have time later and you want me to go back and do that one on the first page that was tricky, I can. There's also an example underneath this I could do if you needed me to, but I'm going to keep going, okay? This is a retake on section 4.4b, I believe. Part of 4.4b also has a write an example, a write an equation. I'm going to do the one at the bottom of page 4. Because this is very much like the one on the quiz. This is literally a snip of a Delta math question. Okay, whether or not you need a phase shift for this is determined by whether you look at this as a sine or cosine graph. When I called on someone's second hour, they immediately said I wanted to do a cosine graph. That was actually my first reaction as well, but if you do a cosine graph, you need a phase shift, right? Do you want to do a cosine graph, or does some of you... It crosses here, so we could do it as a what? Sine graph. If we do it as a sine graph, it will not need a phase shift. I will show you both. Sine graph is probably easier, so let's look at the red. What is the midline? That's usually what I find first. -1, which means the vertical shift is down 1. Tell me something else. Cheyenne? What do you think, guys? Amplitude 3? From -1 up to 2 and down to -4. That seems like an amplitude of 3. Good job. Alexa? If you're calling it a sine graph, it started at the midline, finished at the midline at 6 pi. Okay? Now, if you had called it a cosine, it would have started here and finished here. But if you took 15 pi over 2 and you subtracted 3 pi over 2, I don't know why there's a negative there. The difference between those, okay, would have been 12 pi over 2, which is still a period of 6 pi, okay? If you had done here to here, it's still a period of 6 pi. All right, then how do you go back and find B once you know that? It's 2 pi divided by B equals period, or 2 pi divided by the period will give you the B value. So 2 pi divided by 6 pi is just 1/3. Everybody good? Phase shift. What did we decide if we were calling it a sine? It didn't need one. Okay, so someone tell me the equation. Alexa?
3 sine theta divided by 3 minus 1.
Okay, you can do theta divided by 3 or 1/3 theta or 1/3 x, I don't care. And then a minus 1. Okay, was the midline. If you called it a cosine, look at my blue for a minute over here. The amplitude is still 3. It is a cosine. The B value is still 1/3, but you would have started where? Is it 3 pi over 2, guys? To the right, 3 pi over 2, and you would need some extra parentheses in there, and it's down 1. The only thing that changes is the phase shift. The B value, the midline, the amplitude don't change. So it's whatever you saw first. Either one of those is correct, and there's actually infinite right answers. Please don't get too crazy and complicated, because then I have to try to figure out if it's right. But all right, this is back on page 1. This one is very tricky. You can try it tonight. I think what makes it tricky is you have to subtract those to find the period. Is that 5/6 and 1/3, guys? 5, 6 minus 1/3 would be, this would be 2, 6, so you get 3, 6, or pi over 2 is the period. This one it needs a phase shift, yes. This one on the front page would need a phase shift either way because it does not, it doesn't cross the y-axis anywhere nice, okay? That one's way harder than on the quiz though, I promise. All right, second section of the quiz tomorrow is 4.5. I'm just gonna go over exactly what you need to know for the quiz. Does that sound like a plan? You need to know how to graph 2 periods of the tangent. It'll say graph 2 periods and give the intercepts and asymptotes for those 2 periods. Anybody know what the tangent graph looks like?
Yeah.
Okay. And it goes through 0, 0, right? The cotangent graph, this is back on the middle of page 2, by the way. If I had said to graph the cotangent, it does not go through 0, 0. Okay? That would be cotangent. Tangent goes through 0, 0. Where are the asymptotes? Yes, negative pi over 2, positive pi over 2. The next one would be 3 pi over 2. And it would have another period crossing at pi, because the period is pi. So if it crosses once at 0, pi later it's crossing again. So you would say, here's 2 periods. The intercepts were at 0, 0, and pi 0. And the asymptotes were at x equals negative pi over 2, positive pi over 2, and 3 pi over 2. You could just write that as a list. I don't care. I wrote it 3 times separately because they're going up and down. Okay. This would be a cotangent graph, but it's not on the quiz. If you have to do a retake, you might need to know the cotangent, but cotangent would repeat again over here. It would cross at pi over 2. This would be an asymptote at pi. All right, can I move on and talk about secant and cosecant? Anybody need more time on this? All right, one of these is given and you have to determine which one it is. Here's my hint. Secant is the flip of cosine, right? Cosecant is the flip of sine. The cosine has symmetry with what? It starts at the max. Yes, it has symmetry with the y-axis. Does everybody see what I'm talking about? Okay, that is a cosine graph that I just drew. So its reciprocal takes all those little u's and flips them over. Do you see the symmetry is still with the y-axis? Okay, I can fold the left half to the right half and it'll match up. Yes. This would be 0 and this would be 2 pi. But it's going to give you the graph and you have to determine, is it a secant or a cosecant, okay? Nope. Not unless you have to do a retake and then no promises. Okay, so as long as you can identify that that is the secant, because it is the flip of cosine. Mind you, the little dotted line is not going to be there. But you could definitely draw that dotted line in to help you, right? Okay. The sine graph, on the other hand, goes through the origin and does this. What kind of symmetry is that? Yeah, that's origin symmetry, and let me show you. So I'm going to give you the red graph without any dotted anything, and you're going to have to determine that is the cosecant. Let me see. I did this last hour and it worked. Let me see if I can do this again. Okay. If I select all this, yes. You just have to identify which it is. It's already graphed. Okay, guys, look closely at this one. You see the first loop is up here to the right of the axis, right? If I flip it, I know it's now got more stuff on the negative, but do you see that it has symmetry with the origin still right there? Okay, so it has origin symmetry because I can flip it and it looks the same. All right. So it was sine because of the origin symmetry, so it is a cosecant graph. Moving on, the bottom of page 2, my student observer taught this in the second hour class, but at the bottom of page 2, the third section of the quiz tomorrow covers law of sines and cosines. You are asked to state one version of the law of cosines and one version of the law of sines. So somebody state one of cosines for me. Anyone? Anyone? Jeremy. Everybody okay? What is law? Could you have the different letters in different places? Yeah. Whatever you started with, though, should be what you end up with, and the other ones should be the other two. All right. Law of sines is sine of something over something equals sine of something over something, okay? Capital letters, angles, lowercase letters, sides. Now, I gotta tell you, when I glance at this on the quiz, I'm gonna go, yeah, that looks close. Because do you think you're not gonna be able to do the rest of this if you can't state those, right? So I probably won't spend a lot of time glancing that you wrote the letters correctly. All right, you don't have to state the area formulas on the quiz because they're on your reference sheet. But do you remember what the two formulas are called or look like? The semi-perimeter you need to find Heron's formula. That's where you add the 3 up, divide by 2, and then it's this craziness. And I don't care if you don't write it on your notes. That's up to you because it is on the reference sheet. And remember the other area formula? It is on the reference sheet, but it goes 1/2. It's sine of C. Yep. Do you see where this is, guys? On your reference sheet. This is literally off your reference sheet. There you go. Okay, 2 different area formulas. All right, do you need me to do an example of an area formula? Yep. So this is, I believe, number 1 at the top of page 3. It says you have some triangle XYZ. That's not an X or a Y or a Z, Hoffbauer. Let's try that again. X, Y, Z. And it says angle X is 60 degrees. Side Z is 14. Side Y is 6. Does everybody see that you're given 2 sides and an angle in between? So then the area would be it would be half the product of the 2 sides times the sine of the angle in between. Type. What mode should I be in? Which it would say at the top of the page. Degrees, because this is a 60-degree angle. 0.5 times 14 times 6 times the sine of 60. I got 21. And these were miles in the directions up here. So this should be square miles. Good? Okay. This is, you would need Heron's formula for, number 2. If we have time, I can come back and do it if you need me to. I will tell you the one on the quiz is not this ugly. Because if you add this up and find the semi-perimeter, it's like 17.3 or 19.3 or something is your S value. That's a lot of typing, right? Because you have to keep putting that in. I can come back and do it if you need me to. Yes. Mode. Did I type it wrong? I typed it wrong. Oh my gosh. 0.5 times 14 times 6 times the sine of 60. It's 36.4. Great. I am recording for the video. It's 36.4. Hate when I do it wrong. Thank you. Did someone else get that now? 36.4? All right. Number 3 I want to do together. This says find angle E. What are we going to have to do here? Law of cosines, because we know all 3 sides. Law of sines would be if we could set up a proportion, right? But we don't know any angles, so we can't just set up a proportion across from each other. All right, we're going to have to say, if you're finding E, you would start with the side across from it. So we do 21 squared equals, then what? No matter which side you use next. 26 squared plus 28 squared minus 2 times 26 times 28, whatever order, times the cosine of E. Okay, a lot of people can write that down right and they can't type it correctly. Do you remember what we do first? Yes, we're going to subtract these over the other side. You could add them and then subtract it. That would work, but I've been doing it this way the whole time. So I'm going to subtract all those over the other side. Left over here, I have a -2, a 26, and a 28, all multiplied by the cosine of E. If I type 21 squared minus 26 squared minus 28 squared, I get negative 1019 over here. Anybody else getting that? If I type -2 times 26 times 28, I get negative 1456 times the cosine of E. So what do I need to do yet? Yes, I need to undo this multiplication by dividing. And then I'm going to have to undo cosine by doing inverse cosine. And you certainly could have, typed some stuff so that you could make that shorter, but second cosine of 1019 divided by 1456. Either put both negatives in or neither negative, but I got 45.6 degrees. Anybody? Okay. Can you have more than one answer when you do law of cosines? No. Given side, 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 that does determine one unique triangle. And if you were graphing a cosine graph, by the time you got to 180 in degrees, you would have only had one answer each. There's no repeating. Okay. I am going to jump. What? 45.6. Yes? Okay. I'm going to jump to number 6. You can change this to say find angle C because that will make it similar to the quiz question. A, B, C. Angle A is 63 degrees. Side C across from angle C is 35 kilometers. Side A across from here is 34. And we are to find angle C. Okay, before I go any further, can anybody tell me what this is called, what this situation is called? I have 2 sides, and an angle. Is the angle the one in between those two sides? No. So it's called this. Don't tell anybody. Okay? Or it's called SSA. Can we have that? What that means, it does not determine one unique triangle. Okay, we're still going to use law of sines to set this up, but it means there could be more than one possible triangle. Whenever you're doing inverse sine, there could be more than one possible triangle, or there could be no triangle. All right, so tell me how to set this up. The sine of what?
63 divided by 34.
Is the sine of c over 35. Okay, if I cross multiply, I would have 35, is that right? Times the sine of 63, close parenthesis, and then divide by 34. Did I remember it right or not? Okay, I got 0.9172. And then I need to do inverse sine of 0.9172. $66.5. Does anybody remember how we find the second possible answer?
Supplement.
Yep, so we do 180 minus that answer. And we get 113.5. Now, this is what I want to show you. When the calculator said 0.917, everybody with me? If I had typed the sine of 66.5 or the sine of 113.5, both are 0.917, okay? It doesn't know the difference. It only gave me one answer. Can we eliminate either of those here? Okay, they're both bigger than 63 degrees, right? Because this is a side of 34 and a side of 35, so this angle should be bigger than 63. They're both bigger than 63. Can you have a 63 and a 113 in the same triangle? Yeah, barely, but yes, you can. So we cannot throw either of these away. Why do you think I did that one today? Oh, maybe there's one like that on the quiz, okay?
Maybe.
All right, again, it was two sides and an angle not in between, or it was using law of sines backwards to find an angle. Should I not leave this written on my quiz? I don't know, really, I don't care. I don't think it's that bad of a word anymore, is it? Pretty sure teachers say that word. Okay, the last section on law of sines and cosines is application problems. There are 3 of them on the quiz. On the quiz, guys, there's one area of each kind, one law of cosines of each kind, and one law of sines of each kind. 3 of those, I just give you a picture, and the other 3, I give you an application. Does that make sense? I don't make you do any kind more than once, I don't think. All right, but this is an application problem. It says here's the home plate to first base is 90 feet. The guy had to run 10 degrees off of that line, 120 feet. There was a pop-up hit out here. So how far does the first baseman have to run back to get here? So there was a 10-degree angle in between here. What are we going to use? Yeah, I know a 10-degree angle in here, but I don't know anything across from it, right? And I don't know any of the other angles inside the triangle. So I do have to do law of cosines. I will have x squared equals, a lot of typing, 90 squared plus 120 squared minus 2 times 90 times 120 times the cosine of 10 degrees. Okay, did he have to run 1,228 feet to catch the pop fly? Or to get back to first base, I guess. No, that's what? That's x squared. Yeah, I need to square root. And I got 35 roughly. On some of them, on some it's not. Okay. Yeah, I don't like the wording for this one either. No, I tried to make it very straightforward. Like here, the number, there's a triangle drawn, but it's not labeled. Okay. Like here's one I gave you, I think. There's a triangular piece of land with sides of 6, 8, and 10. Find the area. Okay, I think you can handle that one or something. But this says students determine, okay, they're trying to measure how far apart A and B are, the trees at A and B. The students determine that the angle formed by tree A, dry point C, and tree B is 27. So if I give you 3 letters, where does the angle measure go? In the middle, so at point C is 27 degrees. Then it says they know that angle ABC is 85, so where am I going to write 85? At B. And it says A to C is 150, so that's this guy down here.
How about these kids? These kids didn't just count how long it is, but they count the angle at each tree. If that makes sense.
Never know. Ridiculous application questions all the time. All right. What can we use here since they're across from each other? Law of sines. The sine of 85 degrees is across from a side of 150. In the same way, the sine of 27 degrees is across from a side of x. Do we need to worry about 2 solutions? No, because we're finding a side. If we're given 2 angles and a side, so we really know all 3 angles, right? We could find the third one if we needed it. So anytime you have one side and all the angles, you're going to use law of sines, and it's going to be one solution only. So 150 times the sine of 27 divided by the sine of 85. Anybody get an answer? 68.4? Is it round to 0.5 or is it 0.4? Okay. Yes. Law of cosines always has an exact answer either direction. Law of sines always has an exact answer, or only one answer when you're finding a side. It's only when you find an angle. And this was a distance in feet, guys. Everybody good? Okay. That leaves us with trig modeling. On the last section of the quiz is 4.4c. This is back on the bottom of page 1. The review is not in the right order as the quiz. I apologize. I wrote the review, got it run off, and then I finished putting the quiz together and I moved some things around. So there are 2 trig modeling questions for you to choose from. You can do them both, but you're gotta tell me which one you want me to grade. Okay. It's more likely you're going to have to pick between the 2 before you run out of time. But extraterrestrials. Researchers find a creature from an alien planet. Its body temperature varies sinusoidally with time. 9 minutes after they start timing, it reaches a high of 130. Then 40 minutes after that, it reaches its next low of 108. Someone tell me something I should put on my graph. Okay, 108 was its low and 130 was its max. Sean is over here calculating what, Sean?
Midpoint, which is 119.
Okay, so he averaged those 130 and 108 and divided by 2 and got 119. So that's our midline. Or this is a total distance of 22. Yes, guys? So 11 to the midline and 11 this way. Total of 22. Puts that at 119. And what's our amplitude then? Is 11. Okay. Now what?
Period.
Okay, it starts at 9. It's at its high, right? 9 in, it's at 130. So do I really know where we started timing? No. But what do I know? It hits its next min 40 minutes later. Be careful when it says that. Doesn't mean it finishes at 40. It means it 40 in length. So that could be 49. Is that a period?
No, it's not.
That's half a period. So how long is the whole period? 80 minutes. From a max to a min is only half a period. You'd have to go out another 40 minutes or to 89 to be back at the max. Okay, are we ready to write an equation or not quite? We're going to use sine or cosine? Cosine, do we need a phase shift?
Yeah.
Right 9. So we would have y equals amplitude 11 cosine. We need a b value to throw in here. If the period is 80 minutes, then b is 2 pi over 80 or pi over 40. I don't care which you put in the equation. And you said to the right 9. Don't forget your both sets of parentheses. And the midline was up at, okay, what mode do we need to be in? If we are graphing, we need to be in radians. It will say that at the top of the section, but if you don't read directions, guys, if you graph and you just get a straight line, not any kind of wave, you're probably in the wrong mode. Okay, for an X window, it wants us to go out to 55 seconds to make our prediction. So you might do like 0 to 60. For the Y, the temperature was up to 130. So you might do 0 to, I don't know, 150 for the Y. Okay, I would be doing this if I were you so that you can double check that you are getting this to work. 11 cosine pi over 40, another parenthesis, x minus 9, close both, plus 119. We said out to at least 60 because they want us to check at 50 or 55 or something. And then up to, I said I was going to go to 150, but yep. Yeah, that's a typo from my part. Yep. I have something wrong still. So is this 60 not the whole period? Oh, 89 would be the whole. Didn't we decide it wasn't going to, we'd have to go out to 89 to see a whole period? Yeah, that was my fault. I didn't write the window out that far. And you really don't have to. What did you ask about? Oh, yes. It says in the question, it's talking about minutes, and then this says seconds. This should say minutes. That's my fault. Not trying to make you do any conversion. Okay. So if I were to trace at 9 minutes, it's at a max of 130. At 49 minutes, it's at a min of 108. Is it 50 or 55, guys, that they want us to do? 55? I got it 55, 109.2 degrees. And equally weird, we did that equation in radians and then the answer was in degrees, but That's because that's how we always graph things, is in radians. Okay. I don't know how much time I have left, but I'm talking about the last one quickly. A dead fish question. Awesome. It says there's some paddle wheel. This paddle wheel has a diameter of 12 feet. Okay, I start my watch, and after 4 seconds, it's at its highest, 8 feet out of the water, my dead fish. Okay, takes another 30 seconds, and that fish is back at the top again. So 30 seconds later would be at 34. It's back at the top. Okay, anybody remember how we figure out how low this fish goes? If it's 12, yeah, halfway through it goes to the bottom, but we got to figure out where that bottom is. If it's 12 feet across and it only comes 8 feet out of the water, where's the water at? Yeah, the minimum of the wheel is down at -4. So it would look like this. Okay, I'm going to jump to the equation because I'm going to run out of time. If I average 8 and -4, I get 4 divided by 2 is 2. The midline is at +2. So I have a +2 on the back. What's the amplitude? 6 above and 6 below. It should also be the radius. Is the amplitude. So we got a 6 out front. I'm going to call it a cosine. Shifted to the right, 4. So now I need to figure out what's the period. 30, so we can put a 2 pi over 30 or a pi over 15 in there. Okay, I need to change my window a little bit. I'm supposed to go out to 50 seconds. But what about up and down? Okay, so I'm going to go back here. And I'm going to turn on this equation. And I'm going to go down here and say -5 to 9. And what did they want to know? Well, was it 4 seconds and it hit the top of 8 feet? Okay, what do you want to know? 50, 55, 50? At 50, I'm getting -3.9 feet. So it's 3.9 feet below the water. Okay. Right here, quickly. Make sure you have homework check 3 ready to turn in tomorrow. That includes the work from the Delta Math on law of sines and cosines. Some of you accidentally stapled that into your last homework check, so find it. You also need to have law of sines, cosines, and tangent, graph.
Can I have a homework check again?
Can you check over there?
Yeah.
Is there extra check